On July 29, an earthquake measuring 8.8 struck near the shores of the Kamchatka Peninsula in eastern Russia, raising concerns about potential tsunamis. Surprisingly, no significant tsunamis followed the quake, which scientists attribute to the region's geological features. This earthquake ranks among the 6 largest recorded in the past century, echoing fears similar to those following the devastating 2011 Japan earthquake and the Indian Ocean earthquake in 2004. However, the resulting tsunamis caused minimal destruction. The quake occurred at a depth of 21 kilometers in the Kuril-Kamchatka subduction zone, where the Pacific plate descends beneath another tectonic plate at a relatively high speed of about 75 mm per year. This area features a gentle angle of subduction, allowing a large portion of the fault to be primed for slipping. According to Rich Briggs, a geologist at the U.S. Geological Survey, this area essentially acts as a factory for earthquakes. Just 2 weeks prior, the region experienced a 7.4 magnitude earthquake, and last year, a 7.1 magnitude quake. In 1952, one of history's largest recorded earthquakes, measuring 9.0, also struck Kamchatka. Hours after the earthquake, the largest active volcano in the northern hemisphere, Klyuchevskaya Sopka, erupted. While the timing was coincidental, it remains uncertain if the two events were directly related. The Kamchatka earthquake did generate tsunamis, but their strength was significantly lower compared to tsunamis from major earthquakes like the 2011 Tohoku quake. Submarine earthquakes in subduction zones can displace enormous volumes of water, creating larger tsunamis, especially when the earthquake originates closer to the seafloor. In this case, the earthquake's epicenter was at a relatively shallow depth of 21 kilometers, which limited the movement of water. Reports indicate that waves of 3 to 5 meters impacted the Kamchatka coast, flooding the coastal city of Shuro-Kurilsk. About 6 hours after the earthquake, tsunamis reached Hawaii, with a maximum height of 1.5 meters reported. Crescent City in California experienced waves around 1 meter. Millions in the Pacific region faced evacuation alerts, but most waves observed were small, leading to many warnings being later rescinded or adjusted. While this precautionary response was warranted, even minor waves can still pose dangers. One reason for the weak tsunami was the earthquake's depth and the lack of fault movement reaching the seafloor. Unlike the Tohoku or Indian Ocean earthquakes, it appears that the fault movement did not extend to the ocean floor, resulting in less water displacement and weaker waves that had less potential for damage over long distances. A similar situation occurred in Chile in 2010, where an 8.8 magnitude quake caused local devastation, but the resulting distant tsunami was relatively mild. Additionally, the shoreline's configuration influences tsunami destructiveness. Narrow bays and sloped beaches can amplify wave energy. Overall, the recent tsunami reports align with the characteristics of the earthquake and its location. Since the quake, numerous aftershocks over magnitude 5 have been recorded, including one at magnitude 6.9. According to predictions from the U.S. Geological Survey, there is a 60% chance of an aftershock greater than 7 in the coming week. Experts warn that any earthquake could serve as a precursor to a larger shock, urging people to remain vigilant. For example, on July 20, which was less than 2 weeks before the recent earthquake, a magnitude 7.4 earthquake also occurred in the same area. However, over time, the likelihood of a stronger earthquake decreases. According to the U.S. Geological Survey, there is on average only a 5% chance that an earthquake will be followed by a larger one in the same vicinity within the week after the event.